Hello guys, I hope you are fine. So in this video we are going to look at science paper 2 or chemistry prediction for 2023 internal candidates. So if you are new to this channel, kindly subscribe for more videos and thanks for your support. Okay, so the first topic which is likely to come in your paper is the introduction to chemistry. So now on this part here, they are going to ask you to describe what chemistry is. Now they can't ask you to describe what chemistry is on section B. They can only ask you what chemistry is on section A. Apart from that one, you need also to classify the branches of chemistry. For example, like analytical chemistry, biochemistry, inorganic, physical and organic chemistry. And you need to explain the next one. You need to explain the importance of chemistry. So on this part here, this question can usually comes on section A and section B. So if they ask you to explain the importance of now on section A, they can't say explain, but they are going to say which one of the following is the importance of chemistry. So the answers, you are going to say improve life through manufacturing of soaps, or you can say cosmetics, detergents, plastic, sugar, cement, paper, medicine, and also food production and other life necessity. Apart from that one, this question which is saying describe the challenges. So if they ask you to describe the challenges of chemical industrial activities, the answers that you are going to give is the production of undesirable harmful byproducts. For example, you can say this one causes what? Air pollution, land pollution, and also water pollution. Let's say, for example, during the manufacturing of cement or during the manufacturing of chemical fertilizers, you're going to find that the chemicals, they are going to come from where? From the industries, and those chemicals, they are going straight to the what? To the livers, thereby what? Polluting the livers. Okay, so apart from that one, they are going also to ask you to demonstrate an application of safety in the laboratory. Now on this part here, they are just asking you to give them, they can say list 2 laboratory safety rules, list 3 or 2 laboratory safety rules. For example, you can give them as when you're doing an experiment. When you are doing an experiment, you need to wear what? Goggles. Apart from wearing the goggles, you can also wear what? The overalls. Apart from wearing the overalls, you can also wear the what? The gloves. Okay, so those are the safety precautions. Apart from that one, you can also give them, let's say for example, if you enter the laboratory, you are not required to touch any chemical without being told by the teacher. Okay, so those are the safety rules. Apart from that one, the topic which is likely to come in your paper is the criteria of purity. Criteria of purity, they can say describe the differences between a pure substance and a mixture. So now, under a pure substance usually is composed of only one thing. Okay, so a pure substance is composed of what? Only one thing. Let's say for example, if you talk of elements, if you say calcium is an element, which means it only contain one thing, which is what? Calcium. Okay, so now if they ask you to differentiate between a mixture and a pure substance, always a pure substance has the melting point of 0 degrees Celsius. Then the boiling point, it is what? 100 degrees Celsius. Okay, then as for mixture, they differ. Okay, as for the mixture, you're going to find that the boiling point is going to increase or it is going to be reduced. And also, similar to the melting point is going to be increased or reduced. Okay, it depends. Apart from that one, you need also to demonstrate how to determine the purity of a substance. Let's say, for example, if they give you different melting points and boiling points, Let's for example, you can say substance X has the melting point of 0 degrees Celsius and boiling point of 100 degrees Celsius. Then substance Y has the melting point of -10 and the boiling point of 110 degrees Celsius. Then they are going to ask you which one of these is a pure substance. Now here I was saying a pure substance has the melting point of 0 degrees Celsius, then the boiling point of 100 degrees Celsius, which means X is going to be what? The answer. Apart from that one, you need also to explain the importance of purity of a substance. On this part here, this question may come on section A and also section what? B. Now, if they ask you to explain the importance of purity of substance, as you all know, as for purity, like for example, a pure substance does not contain what? Any impurity. These impurities, they can increase the what? The boiling point and also increase the what? The melting point of a substance. So when you talk about the importance of purity, you are going to say the importance of purity in substance such as what? Foodstuffs. When they are manufacturing foods like drinks, they need to make sure that no impurity should be in any food that they are manufacturing. Apart from that one, medicines, they are make sure when they are manufacturing medicines, they make sure that no impurity should be contained in medicines. Apart from that one, drinks, when they are manufacturing drinks, they need to make sure that no impurity should be in drinks. Okay. Apart from that one, they are going also to ask you questions under separation, let me say separating of mixtures. Now, on that part, they can ask you to distinguish between physical and chemical changes. Now, as for physical changes, we're going to find that physical change, it is reversible. Physical change is what? Reversible. For example, if you take the ice block, then melt it, you're going to find that liquid is going to be formed, which is what? Water. That water, if you put it in a refrigerator, you're going to find that it is going to be frozen, forming a what? An ice. So which means that one is a what? A physical change. Now, when you talk of chemical change, let's say, for example, if you take a paper and burn it, you are going to find that ashes are going to be formed. Now, can you return ashes back into a paper? No. That one is an example of what? A chemical change. Okay. So in terms of the mass, you're going to find that during the physical change, the mass does not change. Okay. During the what? During the physical change, the mass does not what? Change. But when you talk of chemical change, of course, we are going to find that if you burn a paper, the mass is going to be what? Is going to be reduced. Okay. Apart from that one, also the chemical change formed, and also we can say the energy is involved when chemical reaction or chemical change is taking place. Energy is what? Involved. Apart from that one, they are going also to ask you to differentiate methods of what? Separating mixtures. For example, decantation. Decantation, you talk about decantation, you're going to find that when you mix water and sand, when you talk of decantation, you're going to rate, when you mix the sand and water together, you're going to find that for you to make sure that you're taking what? Or you are doing decantation, you are going to rate what? Sand settled down at the bottom of the what? Of the beaker. Then when you let the sand settle at the bottom of the beaker, after some minutes, you're going to find that you're going to pour out now what? Water. Then the sand is going to remain in the beaker. That is what? Decantation. Now when you talk of filtration, you're going to use a filter paper. You're going to use what? A filter paper to filter out the filtrates. So in this case here, you can also separate sand and water. This mixture of sand and water. So you're going to find that sand is going to remain where? On the filter paper, and it is going to be called as a residue. Okay. Then as for crystallization on this part here works when you want to make what? Salts. When you want to make what? Salts. Okay. Let's say, for example, you evaporate some water. You evaporate what? Some water. You're going to find that once all water is evaporated, the crystals of salt, the mix of salt and water, you're going to find that salt is going to remain where? On the evaporation dish. Okay, it is going to remain where? On the evaporation dish. Now, when you talk of crystallization, which means the crystals, they are going to be formed like the way sugar is. Sugar, we can call it as a sugar crystal. Okay, apart from that one, simple and fractional distillation. So on this part here, you need also to know the structure and also the parts, and also examples of substance that can be separated using what? Fractional distillation. Apart from that one, magnetism. On this part here, when we talk of magnetism, which means ions and different types of what mixtures are going to be involved here. Let's say, for example, if you mix what? Iron and sand, you know that iron can be attracted to a magnet, which means you can use what? Magnetism to separate what? Iron from sand. Okay, so apart from that one, you need also to know chromatography. So in this part here, you need also to know how to determine what? Soluble substances and insoluble substances using a what? A chromatograph what? Paper. Apart from that one, you need also to know how to determine the what? The retardation factor. So retardation factor is equal to what? Different distance traveled by what? By solvent over distance traveled by what? Spot. So I'm saying retardation factor is equal to what? A distance traveled by what? Solvent over distance traveled by what? Spot. Apart from that one, they're going also to ask you to explain about evaporation. Apart from evaporation, they can also ask you to explain sublimation. So you need also to know examples of substances that can undergo what? Sublimation. For example, iodine crystals. Iodine crystals can undergo what? Sublimation. As for sublimation, you're going to find that a solid is going to change direct into a what? A gas without passing through a what? A liquid state. Apart from that one, you need also to identify flotation, use of a separating funnel, and centrifugal. Like for example, if they want to separate blood cells from plasma proteins, they use what? Centrifugal. Apart from that one, you need also to interpret simple paper chromatography, like the way I was saying on this part here. You need to determine the what? The retardation factor. So distance traveled by a component to a paper. Okay, so that is what? The chromatograph or chromatograph. Yeah. So apart from that one, they are going also to ask you to describe the formation of what? Covalent bonds and what? Bonding. They can ask you what? To describe the formation of what? Covalent what? Bonding. Now when you talk of covalent bonding, covalent bonding involves what? Non-metals. For example, if you talk of carbon dioxide contains what? Two elements. That is what? Carbon and oxygen. So carbon is a non-metal and also oxygen is a non-metal. Now when you talk of covalent bond involves what? The sharing of electrons. Okay, sharing of what? Electrons. So now on this part here, we can talk of chlorine, which is a gas. Apart from that one, methane. Okay, methane, which is also a gas, hydrogen chloride, and also ammonia. Those are the examples of what? Compounds which can undergo what? Covalent bonds. Apart from that one, they can also ask you to describe the electronic arrangement in a simple what? Multiple covalent molecule, such as double bonds in oxygen, and also in what? Ethane, and also carbon dioxide. Triple bond, like for example in nitrogen gas, and also ammonium. Let me say ethene. Okay, so those are the what? The examples. Now sometimes in an exam they can ask you what? Let me say they can give you a what? A structure which is falling under what? The structure or the electron configuration, or the structure of the covalent bond, and then they are going to ask you to determine if it is a single bond, double bond, or triple bond. Apart from that one, they are going also to ask you to describe the uses of what ionic and covalent what bonds. If they ask you to describe the uses of what ionic and covalent bonds, you're going to give them the answer like this one. So as for ionic and covalent bond, we use them in polar and non-polar what solvents. For covalent bonds, we use them what in polar and non-polar what solvents. Okay, for solvent what compounds. Apart from that one, they are going also to ask you to describe what a mole is. What is a mole? To describe what a mole. So a mole, or let me say a molecule, not a mole. They are going to ask you to describe what a molecule. So a molecule is just a smallest particle of an element or a compound which exists independently. So a smallest particle of an element or compound which exists independently. Okay. Apart from that one, they are going also to ask you to describe the uses of radioactive isotopes. They are going to ask you to describe the uses of what? Radioactive isotopes. Now, on this part here, if they ask you to describe the uses of radioactive isotopes, the first one you're going to say in the treatment of cancer. Apart from that one, industrial use as tracers. So it is used in industrial use as the tracers or treatment of what? Cancer. Apart from that one, you need also to know how to demonstrate the building up, the build up of electrons in shells. So the first shell should be accommodated by 2 electrons. Then the second shell should be accommodated by 8 electrons. So as for an element to become stable, the electrons in the outermost shell should be what? 8. So metals, they lose electrons. Then non-metals, they do what? They gain electrons. So when a metal loses electrons, it becomes a cation, or it becomes yes, a cation. And when a non-metal gains electrons, it becomes what? An ion. Okay. Apart from that one, they can also ask you to describe the formation of ions. That is what? The radicals. Formation of what? Ions, which is the what? The radicals. So cations by electrons lose, anion by electron gain. Okay, so like the way I was saying, metals, they lose. Once they lose electrons, they are going to become what? Cations. And when nanometals gain electrons, they are going to be called as anion. Okay. Apart from that one, they can also ask you to describe the formation of ion, electrovalent bonds. So now, if they ask you that one, which means you are going to explain it like this. Okay, as for the lose and gain of electrons between metallic and non-metallic atoms, ionic bonds has electrostatic force between cations and the anions, such as what? A sodium chloride. As for sodium chloride, it is falling what? It is falling under what? Ionic, which means as for them, sodium is a metal and chlorine is a non-metal, which means for between them there will be a strong attraction. Since metals, they are positively charged, which means as for sodium it is positive, and then as for chlorine is a non-metal, which means it is a negative. So negative and positive, they do what? They attract. They have what? A strong attraction forces. Okay. Apart from that one, you can also give them as a magnesium oxide. Okay. Apart from that one, they are going also to ask you to describe an element. So an element is just a substance made up of same chemical atoms. Okay. Apart from that one, they are going also to ask you to identify elements using their chemical symbols. Like for example, they can give you a weight equation. They can give you what? A weight equation. Then they can ask you to write a chemical what? Equation, which means you're going to use what? Symbols or chemical symbols. Like for example, sodium. The symbol for sodium, or the chemical symbol for sodium, is what? Capital letter N and small letter what? A. That is what? Sodium. Apart from that one, they are going to ask you to describe the basis of the periodic table. If they ask you to describe the basis of the periodic table, which means they are going to ask you to determine the periods. Okay, so horizontally. Okay, so when you go on the periodic table, horizontally, the horizontally determines what the period in which what elements, or on which what an element is what is found. Okay, so elements which are in period 1, they have what same number of shells. Okay, same number of what shells. Then as for elements in period 2, they are going to contain what same number of what shells. So the instance here is that elements in the same period, they are going to have what same number of shells, not electrons but shells. Okay, apart from that one, the valences, as for group 1, group 2 and group 3, these are called what metals. So as for group 1 and group 1, group 2, group 3, just take their group as the valence. So for example, sodium is found in what group 1. So the valence of sodium is what 1. Okay, then as for group 4 up to group 8, you subtract the group from group what 8 for you to have the what the valence. Let's say for example, oxygen is found in where? In group 6, which means the valence of the oxygen, first find the valence, we're going to say 8 minus what 6, then the answer is going to be what 2. So the valence of oxygen is what 2. Apart from that one, they are going to ask you to describe an isotope. So an isotope is just what, these are just what elements having what same proton number but different what mass number. Okay, apart from that one, they are going also to ask you to calculate relative atomic mass of an element given the percentage abundance of isotopes and the from mass spectrum. For example, if you want to calculate what the relative atomic mass of an element given by the abundance of isotopes and from mass spectrum, the formula is like this. Okay, so relative, which is at the meter, is equal to percentage multiplied by the mass number of the element, which is an isotope. If they are going to give you 2 isotopes, which means we are going to say percentage multiplied by the mass number divided by what 100% plus another isotope, which is what you're going to be given the percentages. In this case here, you're going to be given what 2 percentages. Okay, so another one, you're going to say percentage multiplied by what the mass number of that isotope divided by what 100%. Then from there now you can do what you can compute. Okay, apart from that one, they are going also to ask you questions under what preparation of what salts. Okay, we may say as bases, let me say acids, bases and salts. Okay, they can ask you questions under what acids, bases and the salts. So under this topic it is very, very highly examinable. Okay, so they are going to ask you to describe an acid, or they can ask you to describe a base, or to describe an alkali, or to describe you can describe in terms of ions they contain or produce in aqueous what solution. So an acid is just what a compound that produces what hydrogen ions as the only positively charged ion in aqueous solution or in water. So a base is generally as an oxide or hydroxide of a metal, including what ammonium. Okay, so hydroxide. As for alkali, alkalis are soluble bases. Alkali are what soluble bases that produce what hydroxide ions in aqueous what solution as the only negatively charged ions. Apart from that one, they're going also to ask you to describe the meaning of weak, strong, dilute and concentrated acid and alkali. So if they ask you to describe the weak acid, as for weak acid, it ionizes partially in aqueous what state, the acid which ionizes what partially in aqueous what solution. Then if they ask you to describe a strong acid, this strong acid, it ionizes completely in the aqueous what solution. Okay, apart from that one, if they ask you to describe the concentrated acid, on this part here you're going to tell them the number of what ions per volume of solution. Okay, apart from that one, an alkali, I was saying an alkali is also what a soluble base that produces what hydroxide ions in aqueous solutions and in aqueous solution are the only positive as the what the only negatively what charged ions. Apart from that one, they are going to ask you to describe the pH scale. So the pH scale usually range from 0 up to 14. So the range from 0 up to 7, it is called what an acidic medium. Then as for 7 itself, it is called what a neutral medium. Then from 7 up to 14, it is called what alkalinity medium. Apart from that one, they are going to give you compounds, and then they are going to, like for example, if they say sodium hydroxide. Sodium hydroxide is a base, which means it is alkaline. Let me say alkaline. Then if they give you sodium hydroxide, let me say, if they give you hydrochloric acid, which means hydrochloric is falling under what team? The pH range from 0 up to 7. Okay. Apart from that one, they are going to ask you to describe the neutrality, acidity, and alkalinity in terms of pH value. Okay. Then apart from that one, you're going also to determine the pH value of a solution, like they were saying. So using a universal indicator, different colors of pH, different colors, let me say colors of different pH values using pH meter. Okay, so another one, they can ask you to demonstrate the characteristics or the properties of acid. So the properties of acid, you can talk of the reaction of the acid with a metal. So when an acid reacts with a base, a salt and water is going to be produced, which is what the neutralization reaction. So when an acid reacts with what a base, that is what a neutralization reaction. The products are going to be what a salt and water only. Okay. So when an acid reacts with what carbonate or metal carbonate or bicarbonate, carbon dioxide, water is going to what a salt, carbon dioxide, and water is going to be what produced. When an acid reacts what? When an acid reacts with what? Carbonate. Three things are going to be produced. The first one is what? Carbon dioxide, followed by what? A salt and the water at the end, or vice versa. Apart from that one, they are going also to ask you to demonstrate or to give or state the characteristic of or the properties of what bases. Okay, so if they ask you that one, you are going to give them in terms of the effect on indicator. So as for bases, they change what red litmus paper green. Okay, then they can also ask you to illustrate the importance of what acid bases reaction. If they ask you to state the importance of acid bases reactions, you are going to give them accordance to controlling the acidity. So bases are used in the controlling of what acidity. Let's say, for example, if the soil is acidic, if you apply a base, for example, if you put lime, okay, if you put what lime or sodium hydroxide. Sodium hydroxide is a base, which means it is going to neutralize that acidic solution or that acid to produce what water and a salt, or a salt and water only. Apart from that one, like treatment of indigestion, brushing teeth with toothpaste. So toothpaste is made from where? From bases and acids. Okay. Apart from that one, they can also ask you questions under what team? Under metals. Okay. Under what team? Metals, or let me say the periodic table. The periodic what table. So now the question which is likely to come under periodic table, the first one is they are going to ask you to describe the harmful effect of what halides. The harmful effect of what halides. Like for example, like let me say they are going to ask you to describe the transition metals. So now on this part, if they ask you to describe the transition metals, so a transition metal is just a broke element between group 2 and group 3 of the periodic table. Apart from that one, they are going also to ask you the properties of transition metals. So as for transition metals, they have what? High density. They have what? High density, high melting point, and boiling point. Apart from that one, they also form colored compounds. They also what? Formed colored compounds. And most of the transition metals, they are used what? As a catalyst. They are used as what? a catalyst. For example, when you talk of nickel is used as a catalyst. Apart from that one, they also use a different what like iron. Okay, iron is also used as what a catalyst. Okay, apart from that one, they are going also to ask you to describe the uses of what transition metals. So if they ask you to describe the uses of transition metals, you are going to give them as transition metals are used as what catalyst. Apart from that one, transition metals are used as alloys. Apart from that one, they are also used in engineering materials. Apart from that one, you need also to know that they are what they are heavy metals, or heavy metals are no longer used to make what paint for healthy reasons. Like for example, if you use heavy paints are more dangerous. They damage what brain cells during what the spraying. Okay, so these transition metals, they are also used in the manufacturing of what paints. Okay, apart from that one, they are also going to ask you to describe the valence. No, now on this part here specifically, they can give you compound. Let me say they can give you elements. Like for example, they're just going to use any symbol, and also they are going to give you the electron number and also the mass number. Then apart from that one, they are going to ask you to determine the valence, the period. Now on this part here, as for group 1, group 2, group 3, their group determines their valence. Group 4, up to group 8. For you to know their valence, you subtract the number of electrons in the outermost shell. Okay, yes, the number of electrons in the outermost shell from group 8. Okay, so on this part, they can also ask you to determine how to demonstrate how to deduce valence of an element. Okay. Apart from that one, you need also to formulate chemical formulae of compounds. Let's say, for example, if you talk of what sodium. Sodium is found in where? In group 1. So which means sodium is a metal. It is going to have what? A valence of 1. Then let's take also chlorine. Chlorine is found in where? In group 7. Which means for us to know the valence, we are going to say 8 minus what? 7. Then the answer is going to be what? 1. So sodium has a valence of 1 and chlorine has a valence of 1. So the valence, for us to form sodium chloride, we are going to extend the what? The valence is Z. Okay. That is the what? The formation of chemical formulae of compounds. Apart from that one, they are going also to ask you to identify the difference in properties of ionic and covalent what? Bonds. Okay. Apart from that one, they are also going to ask you to describe the harmful effects of halides, like pesticides. Okay, pesticides. Apart from that one, they are going also to ask you to describe the uses of what? Noble gases in providing an inert what? Atmosphere. So the significance of their non-reactivity. Okay, so as you can see, or as you all know, noble gases are group what? 8. They have 8 electrons in their outermost shell, which means since they have 8 electrons in their outermost shell, which means they are stable. So they can't undergo any reaction. Okay, so for example, argon. Argon is used what? In electrical lamps. Manufacturing of what? Bulbs. The gas that they use in the manufacturing of bulbs is what? Argon. Or the gas which they use in the manufacturing of what? Electric lamps. It is what? Argon. Apart from that one, helium. Helium is used in where? In balloons. Okay, so helium is used in balloons. Apart from that one, they are going also to ask you to... Okay, so let me try to... Or the topic which is likely to come in your paper is more concept. So more concept is highly examinable. So the first thing that you need to know is how to determine the relative atomic mass and relative molecular mass. So in an exam, they can say differentiate between relative atomic mass and relative molecular mass. So as for relative atomic mass, it has no units. As for relative molecular mass, it has what? Units. Apart from that one, you can differentiate them according to the element of isotopes. Okay, so we can say as for relative atomic mass, It is a what? It is the mass of an elements isotopes of as compared to what? Carbon 12. Apart from that one, as for relative molecular mass, it is also a mass of a molecule as compared to carbon 12. Apart from that one, you need also to know the calculation. You need to calculate the relative formula mass of a compound. Okay. Apart from that one, they can also ask you to describe what a mole is, or they can ask you to explain the term mole or the concept mole. So a mole is just what? The number of quantities of particles, for example, atoms, ions, or molecules. Okay. Apart from that one, they can also ask you to determine the physical masses of any substance using the what? The molar mass, which is Mr, and the physical volume, which is V, of any gas at room temperature and vice versa. So in this part here, what you need to know is that the avocado, let me say, Avogadro constant, the Avogadro constant of an atom or an element is what? 6.02 multiplied by 10 to the power 23. Okay, that is what the Avogadro's constant. Then apart from that one, you need also to apply the formula which connects the number of moles, mass, and Mr, which is the molar mass. Okay, so number of moles is equal to what? Mass over what? Mr. Apart from that one, you need also to know how to apply the formula which connects the number of moles. Number of moles is equal to what? Volume over the molar gas volume. So the volume of any gas at room temperature, it is what? 24 decimeters cube. The volume of any gas at room temperature, it is what? 24 decimeters what? Cube. Okay. So 1 mole of a given gas, 1 mole of a given gas at room temperature, it is what? 24 decimeters what? Cube. Okay. So where N is the number of what? Moles. Apart from that one, they can also ask you to describe the relationship of Avogadro's law to reacting moles and volumes of gases of let me say at room temperature and standard temperature. So now as for standard temperature, so the volume or the volume of any gas at standard temperature is what? 22.4 decimeters cube. Okay. Apart from that one, what you need to know here is that they can also ask you to determine the concentration of a solution and also apply dilution law. As for dilution law, it said that the number of moles of solutes before dilution is the same as after dilution. Let's say, for example, if you add 2 moles in a solution of, let me say, in the volume of 20 centimeters cube, even if you dilute that one, the number of moles they are going to remain what? Constant. Now, number or concentration it is also called what? Molarity. Concentration is also called what? Molarity. So the formula for concentration, we can say molarity or concentration is equal to what? Number of moles over what? Volume. Okay, or we can say concentration is equal to what? Mass over volume. So you need also to apply the dilution law. Okay, so the dilution law states that the number of moles of solid before dilution is the same as after dilution. So M is going to represent what? The molarity or concentration. Then volume is going to represent what? Its volume itself. Okay, so molarity number 1 multiplied by volume number 1 is equal to molarity number 2 multiplied by what? Volume number 2. So this one here you need also to know it. So apart from that one, you need also to illustrate calculations involving stoichiometry, reacting moles and volumes of gases and solutions. Okay. So apart from that one, you need also to describe the calculation. You need to calculate also the percentage yield in a reaction and the percentage purity of a substance. Okay. So the percentage yield is equal to what? The actual amount obtained divided by what? The theoretical what? yield. So the theoretical yield, you're going to get it from where? From the calculations. Then the actual yield, they are going to give you in the question. So the mass which they are going to give you in the question is going to be called as the actual yield or actual mass. Then the one that you're going to find during your computation, you're going to call it as the theoretical yield multiplied by what? 100%. Okay. Apart from that one, the percentage purity has the amount of substance divided by what? The total amount of the mixture. So in this part here, they can ask you to give them the percentage by mass of sodium in sodium chloride, which means on top, you're going to say percentage by mass of sodium is equal to the mixture of sodium over the what? The mixture of all the compounds, which is what? Sodium chloride, multiplied by what? 100%. And then you're going to find the actual answer. Apart from that one, you need also to determine the limiting reagent in a given reaction. So this one here is very, very important. Whether you like it or not, you need to know how to determine a limiting reagent or excess reagent. Apart from that one, you need also to demonstrate calculations involving different types of acid, bases, titration reactions. Okay, so in this part you need to use titration law. Okay, you need to use titration law. So apart from that one, the topic which is likely to come in your paper is organic chemistry. So as chemistry is concerned, organic chemistry, you are going to find it whether you like it. I want you to go and smile in an exam. Okay, so once you enter an exam, whether you like it or not, you're going to find questions from organic chemistry, one from section C, one from section B, and 2 questions or 3 questions from section A, question 18, 19, and 20, somewhere there. Okay, so under organic chemistry, you need to describe the saturated and unsaturated hydrocarbons. So as for hydrocarbons, these are compounds that contains hydrogen and the oxygen only. So they contain hydrogen and oxygen only. That is hydrocarbons. Now when you talk of saturated hydrocarbons are called alkanes. Alkanes are called saturated hydrocarbons because they have a single bond. So now on this part here, what you need to understand is that carbon can form about 4 covalent bonds. Okay. Then as for unsaturated hydrocarbons, they are called alkenes. Okay, they are called alkenes. So now when you talk of organic compounds, these are compounds of carbon other than oxide and the carbonates, which means whenever you find carbon or a compound containing oxide, that one is not it is not falling under organic compound. For example, carbon dioxide is not an organic compound. Okay. Another one, carbonate, like it say of carbonate, carbonate is not an organic compound. Okay, so when you say other than oxide, which means we are excluding oxide and also carbonates. Okay, apart from that one, you need also to describe hydrocarbons, illustrate the structures of the alkenes up to 5 atoms. So on this part here, you need to know the general formula for all alkanes. So the general formula for all alkanes is CnH2n plus 2. That is the general molecular formula for all alkenes, which all alkenes are going to conform. So where N is going to represent the value or the number of carbon atoms. Apart from that one, you need to demonstrate the structures of isomers and their names. Now, when you talk of isomers, these structure compounds that have same molecular formula but different structure formula. Apart from that one, you need also to describe fractional distillation of petroleum. So petroleum is an example of an alkane. Okay, is an example of an alkane. So now, when crude oil or petroleum is subjected to high temperatures, you're going to find that it is going to undergo cracking. Okay, it is going to undergo cracking. Now, those carbon, or let me say those fractional distillation are going to be separated. Those that are going to be those that are going to have what, more carbon chains, okay, or those compounds that are going to contain more carbons, they are going to be separated at the end, or they are going to have what, high melting point. Then those that have a small number of carbon atoms, they are going to have what, lower melting point. At the result, lower melting point and boiling point. So on this part here, as the number of carbon atom increases, the melting point and the boiling point increases. As the number of carbon atom decreases, the melting point and the boiling point also decreases. Okay, so apart from that one, you need also to know the fractional column. The fractional what, column of fractional distillation. Okay, so apart from that one, they can also bring. So alcohols also, they are going to come. Okay, so alcohols are also known as what, alkanes. So they are going to ask you to describe the chemical composition of an alcohol. So the alcohol, they have the general formula of CN H2N plus 1 hydroxide, which is what, OH. Apart from that one, you need also to know how to describe and name structures of prime alcohols up to 5 carbon atoms. So you need also to know how to name using the what, the Rupak, which is what, nomenclature. Nomenclature, and O should be end with ano, okay, or OL. So alcohols, they end, all alcohols, they are going to end in what, OL. Okay. Apart from that one, you need also to describe, to demonstrate isomerism in alcohols. Okay, isomerism in alcohols, and also to describe the formation of alcohols. So alcohols are formed when an alkane, an alkane undergoes hydration. You add water to an alkane. Okay, so that one is what, the reaction. Apart from that one, you can also know other reactions which forms what, alcohols. Okay, so apart from that one, you can also talk of when an acid undergoes what, dehydration. When an acid undergoes what, dehydration, which means okay, let's just forget about that one. So let's move on to the next one, which is saying describe the chemical property of alcohols. So when you talk of chemical properties of alcohols can undergo combustion. So when alcohols undergoes combustion, now under combustion you can have complete combustion and incomplete. So when an alcohol undergoes complete combustion, water and carbon dioxide is going to be produced. Water and the carbon dioxide is going to be produced. Okay, so when it undergoes incomplete combustion, carbon monoxide and the water is going to be produced. Okay, apart from that one, alcohols undergoes what, is esterification. Now, as for esterification, you are going to find that the alcohols, they are going to react with what, acids to form an ester. Apart from that one, alcohols, they undergo what, dehydration to form alkenes. Okay, so alcohols, they undergo dehydration. It's more like you're removing an hydroxide, which is OH, from alcohols to form what, an alkene. And also alcohols, they undergoes what, they undergo oxidation to produce what, acids. Okay, then the next one is saying you need to describe the uses of what, alcohols. So the uses of alcohols, you are going to say it is used as the organic solvent. Apart from that one, alcoholic beverages, or it is used as a fuel. Okay, so alcohol is used as a what, a fuel. Apart from that one, they are going also to ask you questions under carboxylic acids. So carboxylic acids are also what, are also called alkanoic what, acids. So on this part here, they are going to ask you to describe and name structures of carboxylic acids up to 5 carbon atoms. Okay, so on this part here, the functional group of carboxylic acid, it is what, COO, which is what, COOH. Then the general formula, it is what, CnH2 plus C1, COO, which is what, COOH. That one is what, the general formula for all carboxylic acid. Okay, apart from that one, they are going also to ask you to describe the formation of carboxylic acid. So when alcohols undergoes oxidation, an acid is going to be what is going to be produced. Okay, apart from that one, when an ester undergoes what hydrolysis, when an ester undergoes what hydrolysis, how, let me say, carboxylic acids are going to be what or carboxylic acid is going to be produced. Apart from that one, you need to demonstrate the chemical properties of carboxylic acid. Like for example, you talk of the reaction of carboxylic acid with the carbonates and also the products which are produced. So when a carboxylic acid, this one carboxylic acid is falling out under acids. So when an acid reacts with what a carbonate or metal carbonate, whichever way, carbon dioxide, water, and a salt is going to be produced. Okay, so when a metal reacts with what an acid, a salt is going to be produced, and also what water. Apart from that one, alcohols, when carboxylic acid undergoes, let me say, reacts with what alcohols, an ester is going to be formed during the process of what esterification. Apart from that one, you need to describe the uses of what carboxylic acid, like those such as the formation of what esters. Okay, such as what the formation of esters. Apart from that one, you need also to demonstrate. You need to demonstrate what to demonstrate the preparation of what ammonium, potassium, and sodium salts. Okay, so in this part E, esters are also what called the salts. You need also to demonstrate the existence of hydrated salts and differentiate from hydrous salts. So hydrous salts, they don't contain what water of crystallization. Apart from that one, you need also to describe the behavior of salts with reference to the atmosphere, like the hygroscopic, effervescent, and the deliquescent. Okay, so those are the what the questions that they are likely to come in your paper. Apart from that one, they are going to ask you questions under what macromolecules. So as for macromolecules, they are also called what polymers. So all polymers on that topic, all the questions you need to know. Okay, so all the concept on that part you need to know. You need to know how to describe a polymer. So a polymer is just a giant molecule formed from by joining what small unit called what monomers. Okay, apart from that, we need to describe types of polymers. So different types of polymers. We have two types of polymers. We have synthetic polymers and also natural polymers. So synthetic polymers, they are man-made polymers. Then natural polymers, they occur naturally, like cotton, okay, or wool. So apart from that one, these polymers, they can undergo condensation, polymerization, and also addition polymerization. Now during condensation polymerization, water is given out. Then as for addition polymerization, you are going to find that two identical, when you say identical, which means you're talking about same, two identical unsaturated hydrocarbons. When you talk of unsaturated hydrocarbons, you're talking of what alkenes. Alkenes are saturated, and they are unsaturated hydrocarbons. So during addition polymerization, two identical unsaturated hydrocarbons, they are going to react to form a polymer. So now what you need to understand here is that at the end, polymers are open. Polymers are open to allow for another reaction. Okay. So apart from that one, you need also to talk of examples of condensation polymerization, or examples of substance that can undergo condensation polymerization. For example, you can talk of nylon, toluene, and also you need to know their linkages. Like as for nylon, it has the amine linkage. It has what the amine linkage. Okay, so the amine linkage, it is what it is N. Okay, so it is what N for nitrogen, then C for carbon, then the double bond, then we put what oxygen. So that is what the amine linkage. So let me repeat: N for nitrogen, C for carbon, then double bond, we also have oxygen. So that one is what? The amine linkage. Then as for, and also one thing what you need to remember here is that since here I'm saying nylon, it has a amine linkage. Nylon also has the same structure to that of what? Proteins. So proteins, they have the same linkage to that of what? Nylon. Then we also have telanin. Telanin, the linkage for telanin is called what? The ester linkage. It is called the what? The ester linkage, which is what? OC, or C, O for oxygen, then C for carbon, then also a double bond, and also what? Oxygen. So this one is the what? The ester linkage. Okay. So apart from that one, you need also to know the effects of what? Synthetic polymers. The advantages and effects of synthetic polymers. Apart from that one, another topic which is likely to come in your paper is alloys. Okay, alloys. So under alloys, you need to describe what an alloy is. So an alloy is just what? The mixture of two or more carbon, such as what? Steel. So the mix of what? Two or more metals. The mix of what? Two or metals, or we can say carbon, such as what? Steel, brass, and also bronze. So in this part you need to know the composition of what? Brass and bronze. Apart from that one, you need to describe diagrammatically the presentations of what? Alloys. They can ask you to represent what? Brass in form of what? A diagram. Okay, apart from that one, they are going also to ask you the uses of what? The uses of alloys and the methods of you need to explain the advantages or the importance of using what? Alloys over pure substances. So as for pure substances, some they have particles which slide over each other. Now, when we talk of alloys, the advantage is that for alloys, they can conduct what? Electricity. Okay, let me say. They can conduct electricity, and they are also stronger than pure metals. Alloys are stronger than what? Pure metals. Apart from that one, you can take over the weight ratio. The weight ratio and hardness, they are stronger. They are strong. Okay, so alloys, they are strong. Apart from that one, you need to also to identify common uses of alloys, like the sacrificial protein. Let me say it is used in packaging and also in aircraft. So in the manufacturing of aircraft, as you can see, aeroplanes, they are not made of pure metals, because some pure metals are heavy. Okay, so some pure metals are heavy. Now in talk of alloys, they have they have what? Low density. The result, they are used in the manufacturing of what? Aeroplanes. Apart from that one, alloys, they don't collide. Alloys, they do what? They don't collide. Alloys, they don't collide. Okay, so apart from that one, methods of okay, so here I'm saying alloys, they don't collide. So the next topic, which is what? Corrosion. So corrosion, like the one I was saying, alloys, they don't collide. Now here they are going to ask you to describe what corrosion is. So corrosion is just what? A chemical wearing of metals resulting from attack by atmospheric what? Oxygen in the presence of moisture. So as for corrosion to occur, two things should present. The first one is what? Oxygen. Then the last one is what? The moisture, which is in this case water. Okay. Apart from that one, you need to relate corrosion to the activity of metals. You're going to find that as more reactive metal is, they are going to what? They are going to collide easily. When talk of potassium, it reacts vigorous with oxygen, so it is going to collide very, very fast. Okay, then while we can say less reactive metals do not easily collide. Okay, so in this part here, you need to know the reactivity series. Apart from that one, you need also to describe different methods of preventing corrosion, like protecting or sacrificial protection by painting, greasing, or oiling, or alloying, and what? Galvanizing. Okay, so those are the what? The sacrificial protection, or the way of protecting what? Metals from or undergoing what? Corrosion. Okay, so in this part here, you need also to know or to describe the reactivity series of metals. The reactivity series of metals. You need also to describe the chemical properties of metals. You need also to describe the physical properties of metals, and also to describe diagrammatical representation of what? Pure metals. So apart from that one, as chemistry is concerned, the questions are going to come under what? Chemical reactions, where you are going to require to balance a chemical equation, or and also to describe the rate of a chemical reaction. You need to know how to describe the rate of a chemical reaction. You need also to describe methods of controlling the rate of chemical reactions. Okay, so apart from that one, you need also to describe the effect of a catalyst on the activation energy. So if they ask you to describe the effect of a catalyst on the activation energy, so a catalyst lowers the activation energy, thus increasing the rate of a chemical reaction. Okay, so that is the last one. You need also to look at different questions under these topics that I've given you. So that was the last one. Thanks for watching.